The heavens have all larger than anyone had dared to conceive. By the 20th century, with the rise of observatories on remote mountaintops and the spread of photography, the veil was pulled back even further. Cameras attached to telescopes could gather faint light over many hours, revealing galaxies invisible to the eye. Astronomers were no longer limited to what a single night of looking could provide. They could now preserve the heavens on glass plates and study them at leisure, discovering variable stars, novas, and the subtle motions of nebulae. The cosmos revealed itself as dynamic rather than static, a place of birth and death, expansion and transformation. Then came the space age, and with it, a new kind of telescope freed from the blur of Earth's atmosphere. Instruments launched into orbit delivered views of unmatched clarity. The Hubble Space Telescope in particular transformed cosmology, capturing images of galaxies so far away that their light had traveled for more than 13 billion years before reaching its mirror. In those pictures, we saw the afterglow of creation, the faint embers from the universe's earliest dawn. It was as though we had torn a hole in the clouds and glimpsed the first fire of existence itself. Yet, with each triumph came a temptation toward pride. There is a danger in believing that discovery has reached its end, that the last mystery has been solved. The American astronomer Simon Newcomb made this mistake in the late 19th century. He declared that the field of astronomy had reached its limits, that there was little more to learn beyond refining a few details. Within 2 decades, Albert Einstein would overturn the foundations of physics with the theory of relativity, and Edwin Hubble would reveal that the universe was far larger and stranger than anyone had suspected. Newcomb's cautionary tale reminds us that to claim finality in science is always premature. The lifting of the veil is never complete. Each telescope, each equation, each theory disperses a patch of cloud, only to reveal new shadows further ahead. What we now know is immense compared to the knowledge of Galileo, yet it is still a sliver compared to the full grandeur of the cosmos. The lesson of the past is clear. The moment we believe the veil is gone is the moment we are blinded to the mysteries that remain. To lift the veil of the universe is not to finish a story, but to recognize that we are only turning the first pages of a tale without end. In the spring of the year 1920, an audience gathered at the Smithsonian Museum of Natural History in Washington, D.C., to witness what became known as the Great Debate. 2 astronomers stood on stage, each holding a vision of the universe that could not have been more different. Harlow Shapley, a man who had mapped the distribution of stars within the Milky Way, argued that the cosmos was small and self-contained. Heber Curtis, who had studied faint nebulous spirals, argued instead that the universe was vast, containing countless worlds beyond our own. The debate was not simply about distances and measurements. It was about the very scale of existence. Shapley's position was rooted in his extensive work with globular clusters, the dense spherical gatherings of stars that orbit the Milky Way. He believed that these clusters defined the true size of the cosmos, and that the Sun lay far from the center of this system. To him, the Milky Way was enormous, dwarfing earlier estimates, but it was also everything. The mysterious spiral nebulae glimpsed through telescopes, with their faint arms curling outward, were in his view not distant galaxies, but nearby clouds of gas and dust, embedded within our home system. Shapley's universe was large, but bounded, with no need for other island worlds. Curtis, by contrast, embraced the possibility of an uncomfortably large cosmos. He pointed to evidence that spiral nebulae showed signs of rotation, suggesting that they were self-contained systems of stars. He highlighted novae that had been observed within Andromeda's misty light, events that seemed far too bright to occur within a small nearby cloud. Curtis argued that these spirals were not features of the Milky Way at all, but galaxies in their own right, each containing billions of suns. To accept his view was to admit that our home galaxy was only one among uncountable others spread across unimaginable distances,